Okay, so now I'm going to go through some of those Part C calculations that we were planning on doing in the class last week. Just bear in mind a few things first of all. When I say Part C, it's not always Part C of a question, a U-value question. It's the third type of calculation that you could be asked. The way these questions are laid out, there's usually three parts. Part A will always be to calculate the U-value of some element of a house. Alright, it's the easier calculation to do, and it's usually worth more marks. It's usually worth a good 30 marks out of 60. So very important that you're fully aware of that and that you're well up on those and you can do those easily. Part B and Part C of the question can be two of the next two calculations, or sometimes it could be one. So the heat cost and loss calculations that we learned last week, and which I showed you in earlier videos, that could pop up, or also this next calculation that I am going to show you could pop up. Any given question could have both of those other calculations as well, or it might be one of them, and maybe Part C might be just a couple of little notes and sketches about U-values, which we'll talk about shortly. So I'm going to look at the 2011 U-value question. It's in your exam papers. It's on page 76, and I'm going to look at Part B of that question. The Part A of the question is just simply calculate the U-value of a wall. The particular wall we're dealing with, it's an old style wall. It's a cavity block construction. It's got an external render. It's got on the outside and on the inside it's got some plasterboard, and there's also a little gap. The plasterboard is stuck to the wall with dabs of plaster, so there's like a small air gap, and then the plasterboard is stuck on there. Part A is calculate the U-value, which I've done already. I'm not going to spend this video going through that. That's just calculate the U-value. That there is a sketch of the wall we're dealing with. There's the external render. There's a solid block. In the middle, there's dabs of plaster, kind of like glue, which are allowing this plasterboard get stuck to the inside of the wall. So you've got essentially a little air gap there. What they're looking for is a U-value through this section of the wall. They're not asking you to take into consideration these dabs of plaster. So a little thing that could put you off it, just ignore those. Generally speaking, they will ask you just to go through the simplest part of the wall. So you've got 4 layers, 1, 2, 3 and 4. Went through all the calculation. There was actually only 2 parts we needed to calculate the resistance, because they gave us the resistance for the hollow block, they gave us the resistance for that little air space, and obviously they gave us the resistance for the external surface and internal surface. So it was actually quite a straightforward calculation once you figured out the layout of the wall. Okay, the U-value turned out to be 1.564, and that needed to be brought into Part B of this question. If you happen to get that U-value wrong, and you carried your wrong answer into Part B, it's a fresh start. The examiner will do up your calculation with your wrong U-value, and you can still potentially get full marks on that Part B. Alright, so this calculation that we're talking about is basically a retrofitting question. We spoke about retrofitting before. It's basically adding insulation to the wall to improve the U-value. This is an old wall, it's not a good wall, and it's got a high U-value. It's a low performing wall. And nowadays what would be done is they would add insulation to that wall to improve its U-value. Alright. What we're essentially asked to calculate here is how much insulation do we need to stick onto the wall. Alright, because they don't want to stick on too much insulation because that'll be too costly. So they're given a U-value that you need to get to, and you need to figure out how much insulation is needed to get to that U-value. So I'm going to read the question here and take you through it first of all. It is proposed to upgrade the thermal properties of the wall by fixing expanded polystyrene to the external surface. Given the thermal conductivity of the expanded polystyrene is 0.037, calculate the thickness of expanded polystyrene required to achieve a U-value of 0.27 to meet the requirements of current building regulations. Now, having read that, it's a bit wordy, it can be a bit tricky, it can be a bit off-putting. Simply put, they want to know how much insulation must we stick onto that wall to get the U-value from 1.564 down to 0.27. Okay, It says here expanded polystyrene 3 or 4 times, right? That's a fancy word. It's a type of insulation. When you read that, if you just cross over that and say the word insulation, they want to fix insulation. There's a couple of different types of insulation and they use those words and it can put people off straight away. So essentially, we just want to stick on some insulation to the outside of this house to get the U value down to this. We need to figure out how much insulation is needed. Now, steps involved. I've given you the notes for this, so maybe some of you have figured it out already, but I'm going to take you through the steps required. Again, it's the kind of thing, when you do it first, you mightn't be sure what you're doing, but when you do it a couple of times, it actually becomes easy. So, what we need to do is, first of all, we need to write down our existing U value. U value. We're working backwards a little bit here in order to find what we need. So the existing U value, which we calculated in part A, is 1.564. All right. Now, what we actually need, like I said, we're working backwards. We want to find out the resistance in that question. Having done part A, we can see the total resistance is here. 0.639. So existing resistance is 0.639. If you don't have that from the previous question, there is a way of finding out, which we'll be doing in a second. There's the first bit of information we need, 0.639. Now, the required U value that we need to get to, let's just write this down first. So the U value that we need to achieve is given to us in the question. And it says here, the U value we need is 0.27. So we want to get this U value right down. It's way too high at the moment because it's got no insulation. 0.27. Now, the required resistance then so if we're trying to find out how much resistance that is, so we need to find out how much resistance it is. If you want to figure it out, you just put 1, you work in reverse, 1 over 0.27. So, calculator out. And it is 1 divided by 0.27, which gives us 3.703. Okay, now the current resistance of the wall is 0.639. That's not a very good resistance. We want to get the resistance up to 3.703. All right, so what we need to figure out is how much more resistance do we need to get from here up to here. To figure out the difference between those, we just do 3.703 minus 0.639. So calculator out. 3.703 minus 0.639. All right, and that equals 3.064. We need to get the resistance of this wall from we need to add 3.064 onto the current resistance, which will get us to the resistance we need. If we can get to this resistance, we'll get a U value of 0.27. Okay, so at this point then, what we must do is draw up a small section of the table we're used to drawing up. So I'll do it very quickly. Element, conductivity, resistivity. Again, you can do this without thinking at this stage, hopefully. I'm going to put an or there for resistance because I ran out of space. Hopefully that won't happen in the future. So the element we're talking about is the insulation. Okay, the question tells us the conductivity of this expanded polystyrene insulation is 0.037. So 0.037. The resistance that we need to get for this expanded polystyrene is 3.064, which we already figured out. We need to add this resistance to it, and this layer of insulation is going to bring the extra resistance. The resistivity is not given, but we don't need, and the thickness is what we are trying to figure out. Okay, so the formula for this I like to go by, there's a couple of ways of doing it, but I like to do like a TKR triangle. Thickness over K by R. If I ever want to find out thickness, I cover T and it's K by R. If I ever want to find out conductivity, you cover the K, it's T by R. And if I ever want to find resistance, you cover it up and it's T over K. In this particular instance, we're looking for thickness, so we cover the T and it's K by R. So it's this multiplied by this will give us the thickness that we are looking for. If ever they give you the resistivity, all right, and you want to find the conductivity, remember K equals 1 over R and R equals 1 over K, if ever they try and catch you out in some way like that, which they don't usually do. So thickness is K by R, so K is 0.037 multiplied by R, which is 3.064. Calculator out. It is 0.037 multiplied by 3.064, which gives us 0.113. We'll just stop at 3 decimal places. Now that is your thickness, 0.113. Remember, that's in meters. That works out at 113 millimeters. So they want you to add 113 millimeters of insulation to get yourself a U value of 0.27, and that is your answer there. Okay.